Good afternoon, students. Today I am going to cover a last bit of equilibrium chapter, that is space force. If the forces are acting in a different planes, then this kind of force system is being called as a space force. Okay, non-coplanar force system is nothing but a space force. Previously we have learned in a depth about coplanar force system. Now we are going to deal with the force system which may have three planes. Okay, then in the detail I have given the notes. What we are going to learn in this chapter, then how to represent a force in a vector manner, how to work out the moment of a force in a vector, and then how to find out the magnitude and direction of force if the force is given in a vector form, right? First of all, how to represent a force in a vector form. See, in the xy plane, force F is acting, which is the starting point is A and ending point is B. It is acting from A to B. Okay, the force in a vector form will be then force in a vector form is equal to force into EAB. This is nothing but a unit vector. How we are going to work out this unit vector? Unit vector is nothing but a we are having this kind of formula from this point to this point. For that reason, x2 minus x1 will be there. Likewise, y2 minus y1, z2 minus z1. Please concentrate on it. We are going to use this formula throughout the chapter. Be cautious. x2 minus x1 I, y2 minus y1 times j plus z2 minus z1 times k divided by under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. This is nothing but a unit vector. Okay, then f is being denoted by fxi plus fyj plus fzk. Fx is nothing but a means x2 minus x1 times x2 minus x1 divided by this, y2 minus y1 divided by this is nothing but a fy. Okay, well, means we are going to multiply this factor to the f, that is nothing but fx. This factor into f is nothing but fy. Means component of force in x direction, component of force in y direction, component of force in z direction. Previously we used to find out in x and y coordinate only. Means if f is inclined like this and starting from this, then horizontal component and vertical components were there. Now right now we are going to work out three components. Okay, then see, if a exam is of MCQ type, then this kind of concepts should be very much clear to you, and they may ask you this kind of small problems. That's why in this chapter I have taken small problems also. A force of magnitude 650 Newton passes from P to Q. Points are given to you. Put this force in a vector form. What they want? They want F, a force whose magnitude is 650 Newton, in a vector form like this. Okay, then what is your job? First of all, you are having this formula. Unit vector of F is equal to F into EAB, means unit vector of EAB. If the point is if the line is AB, then you should take AB over here. In this case, points are P and Q, then we should take PQ. Okay, then what is F? F is a magnitude given to you, that is nothing but 650 in this case. Okay, so you are supposed to write down as it is. PQ, I told you, for the formula is x2 minus x1, means last point to first point. Okay, then PQ, so Q minus P will be there, means x2 means 5 minus 0, that's why 5. Likewise, minus 3, 4. Getting me? Y2 minus y1, y2 is 0 and y1 is 3, so minus 3 should be there. Okay, then z2 minus z1, z2 is 4, that's why simple 4 will be there, 4k divided by whatever value we are getting here, 5 square plus 3 square plus 4 square. We should not bother about sign because we are adding them, means by squaring and then adding. For that reason, 5 square plus 3 square plus 4 square will be there. So our value will be, if I solve it clearly, then it will become 459.6i to minus 275.76j plus 367.68k. So what they are asking you to work out the force in a vector form. So this is nothing but your vector form. What is value of fx? Coefficient of I is fx. You are supposed to write down like this. Coefficient of j is nothing but fy, and coefficient of k is nothing but fz. Okay, clear? Please try to understand. Then magnitude and direction of force. How to find out magnitude and direction of force? force is being denoted by F is equal to Fxi plus Fyj plus Fzk. See, force is like this, which is right now in this plane, whose inclination with x-axis is theta y, okay, whose inclination is with y-axis is theta x, then likely theta z. Okay, I think I committed a mistake over here. This should be theta y and it should be theta x. Then Fx is a component of force in x direction, y direction, and Fz are the components in y and z direction. Okay, magnitude of force will be under root Fx square plus Fy square plus Fz square. Okay, if we if we refer to last problem, we can find out F by using above formula, right? Means this was Fx, Fy and Fz. Values are very much known to us. Fx, Fy and Fz are known to us. We are supposed to put those values over here. We'll get the magnitude of F. How shall we find out the direction then? Direction means inclination of any inclination with respect to any axis. So Fx is nothing but a F cos theta x. Please do remember these three things. You may get this kind of problems in the case of MCQ. Okay. Fx is F cos theta x, likewise Fy is F cos theta y, and Fz is F cos theta z. We'll look into this diagram. See, this is F. Fx is, if this axis is not given to us, in that case what we used to find out the component in x direction and y direction is F cos theta x if the theta x is inclination, and likewise Fy means in the y direction component will become F sin theta y, theta x. Instead of that, if I use this inclination, then this will become, generally I used to tell you, if I drop this force on this direction, I must add cos to it. F cos theta will be the component in this direction. Likewise, sin theta should be there with y axis. But if I am using this inclination, means I am again if I let it sleep on this y-axis, then it will become F cos theta y. Likewise, F cos theta z will be the components of F in x, y, z axis. For that reason, this kind of components are given to you. And again, it's a cup of tea for you. You are supposed to mug up. Okay, theta x, theta y, theta z are the force directions, value of which lies between 0 to 180. This is an important identity which relates them. Actually, cos theta x plus cos square theta plus sin square theta is equal to 1 is very much known to us. Instead of theta x, right now they have used theta y. Okay, instead of sin theta x, cos square theta y is there. Just to remember this formula, cos theta x plus cos square theta y plus cos square theta z is equal to 1. Then to understand this concept, we are going to solve one problem. Determine the magnitude and direction of force. Again, this is a very short problem, maybe asked for 1 or 2 marks. Okay, F is given to you actually. F is 345I plus 150J minus 290K. Then what they want from you? Work out the magnitude of force and direction, means with respect to x and y and z axis, what is the inclination. Okay, then F is equal to under root Fx square plus Fy square plus Fz square is our formula. Fx is nothing but a 345, Fy is nothing but a 150, and Fz is 290. Just put the value and get the answer like 475. Then we are having this formula, Fx is equal to F cos theta x, likewise Fy is equal to F cos theta y, and Fz is equal to F cos theta z. Then Fx is not known to us, Fx is known to us, and again F is also known to us, but cos theta x is not known to us. Cos theta x formula will become Fx divided by F, that is 345. We can see Fx is 345, Fy is 150, and Fz is 290. And value of F is, just now we have worked out, that is 475. 345 by 475 will give us some value. If I take cos inverse of it, then the answer will become 43.42. Likewise, the answers of theta y and theta z are 71.79, 71.59 and 127.62. Okay, then how to take the moment of the force about a point. In the first case, if the in a coplanar force system, if the force is given to you and you are supposed to work out the moment of this force with this point, with respect to this point, you must know this perpendicular distance. If this is a P and this is x, then moment about O will become P into x. Am I correct? Do you remember this? And in an anti-clockwise way. Likewise, here is some method to find out the moment of this force about this line, okay, or with respect to any point about A, C, how we are going to work. See, this is straight line. The F is given to you, which is acting from A to B, okay. Very sorry. Here F is a force in space passing through point A, that is x, y, z, and x1, y1, z1, and B x2, y2, z2 on its line of action. Let C be the x3, y3, z3 be the moment center at which we are going to find out the moment. We are going to find out the moment about this point. Okay, how we are going to do it then? Few steps are given to you. First of all, find out the force in a vector format, that is fxi plus fyj and plus fzk. Okay, then once you find out the force vector, find out the position vector. Position vector is being denoted by r, that is equal to rxi plus ryj plus rzk. I am going to tell you what is value of this. R is nothing but this distance C to A. Okay, then this minus this we are going to do. Perform cross product of position vector and force vector to get the moment vector. This is the formula R, unit vector of R into force vector. Okay, ijk, just remember this format. Whenever we are going to work out the moment, ijk will be a first row, rx, ry, rz will be your second row. Rx is a distance, right? Ry is also distance in a y-axis, and rz is a distance in a z-axis. Then fx, fy, fz, whatever value of fx, fy, fz are there, you are just supposed to put it here. Okay. One more problem we are going to solve here, just to understand how to calculate the moment in the case of space force. Force of magnitude 50 kilonewton is acting at a point A and towards point B, whose coefficients are given to you. Find moment of a given force about point D, minus 1, 1, 2. These coefficients are also, these coordinates are also given to you. First of all, first job is to find out. Few steps I have given in the last page, that first of all find out unit vector of your force, then find out unit vector of radius. Okay, then put those values in this formula and work out the moment. Line by line we are going to learn it. Okay, first of all, Fe means force is equal to fxi plus fy plus fz should be given to you. If it is not given, we are going to work out. What is the formula for that? F into unit vector of E. Okay, that is EAB. A from we are going to work out unit vector of EAB. Then what is formula for that? B minus A we are going to do. Okay, means x2 minus x1, y2 minus y1, and z2 minus z1. What is x2 and what is x1? See, this is x2 and this is x1. Please do remember, whenever AB word is there, B coordinates of B will be x2, y2 and z2, and coordinates of A will be x1, y1, z1. Okay, then we are going to put all those values over here, b minus a, b minus a, b minus a, whatever I have written over here. We will work out this form, this kind of expression. If we work out it, it will become 21.08 minus 26.35 j minus 36.89 k. Okay, be cautious about sign whenever we are subtracting. Means 6 minus 2 will give me positive 4, but minus 2 minus 3 will give me minus 5i, minus 3 minus 4 will give me minus 7, likewise. Okay, once you find out the unit vector of your force, find out result radius vector. Okay, RDA. Why RDA? Because it is going, means it is acting from A to B, and here somewhere D is there, whose radius vector we are going to work out. The moment of this force about D we are going to work out. For that reason, Rxi, Ryj plus Rzk will be the formula. Unit vector RDA is equal to, means A minus D, as it is very much known to us, this minus this should be there, this minus this. Be cautious about it. Precisely to understand which which will become x2 and which will become x3 or x1. Okay, I already x2 x1 we have used, that's why I have denoted x3 as a coordinates of D, and x1 as previously we have used coordinates of A. Okay, so x3 minus x1, x3 minus x1, y3 minus y1, z3 minus z1 will be there. Means coordinates of D minus coordinates of A, coordinates of D minus A, A minus D, A minus D, A minus D. Why? Because DA was there. If we work out, it will become 3i plus 2j plus 2k. Okay. If you are having any problem or any adson related to this, you will conduct one Zoom class. In that you can ask me. Okay. Then we'll work out the moment of it. RDA into F. Right now nothing is remain now. So first row will be you are means by closing your eyes you should write I j k as a first row. Then second row will be coefficient of unit vector, radius vector. X will be 3, y will be 2, and 2 will be z will be 2. Okay. Likewise, this will be the coefficient of I will be below coefficient means I, and coefficient of j will be below j, and coefficient of k will be below or in the column of k. Okay. Once you know this, how we are going to work out the determinant, likewise we are supposed to solve it. Means I into cross multiplication of these two minus this minus j. If I leave this row and this column, then multiplication of these two minus this, then last one is a k. Okay, then multiplication of these two minus this. Likewise we are going to work out. Then once you know, you are supposed to find out the value in the term of minus 21.08i plus 152.8j minus 121.2k. This is your moment.